So quiz 5 is going to test you on all of the calculation topics that you did in year 10. And because I know calculations are a source of difficulty, I'm going to make a few individual videos for each type of calculation. It's going to be a big part of your mock as well, so it's well worth making sure that you fully understand how to do all of the different types of calculation question. The first one is the use of Avogadro's constant, 6.02 by 10 to the 23. You'll be given this number in the exam. If you're given it in a question, you have to use it. If you're not given it in the question, you do not need to use it. In order to explain how Avogadro's constant works, I'm just going to look at some kind of everyday examples, okay? We see this all the time. We have words in English that represent numbers, so pair represents 2 and dozen represents 12. In chemistry, we have this word mole that represents this number here, which is Avogadro's constant. And the maths that's involved in these calculation questions is really basic. And if we look at some real life examples, you'll see just how basic it is, okay? So if you had 2 pairs of shoes and I asked you how many individual shoes you had, all you would need to do was know that the word pair means 2, and then you've got 2 times 2, you have got 4 individual shoes. And if I changed it from shoes to socks, it wouldn't change how you do the maths. It will still be 2 times 2 equals 4 socks. Okay? Likewise, when we look at a chemistry example, okay, the question would be how many atoms, because elements are made up of atoms. So how many atoms are in 2 moles of carbon? You know the word mole represents this number. You fill that number in for the word mole and you just multiply. And it doesn't matter if I go from carbon to iron, just like it didn't matter when I went from shoe to sock. The maths doesn't change. You just fill Avogadro's constant in for the word mole and you multiply that out on your calculator. Okay. The other type of question you get, again, I'm just going to give you a really basic example so you see how simple this is. Okay. If you had 2 dozen buns and each bun had 10 sprinkles, how many sprinkles do you have in total? Okay. So 2 dozen buns, you're going to need to work out how many individual buns you've got. You know the word dozen represents the number 12. So you know you've got 24 buns in total. And then I'm telling you that each bun has 10 sprinkles, 24 buns, 10 sprinkles per bun. You've got 240 sprinkles. Okay, so very basic maths. If we come over here and look at a chemistry example, in the first few examples, I've given you just elements, so carbon and iron, and they're directly made of atoms. But when I give you CO2, CO2 itself is a molecule. So you've got 2 moles of CO2. The first thing you need to work out is how many individual molecules of CO2 you had, okay? Just like you worked out how many individual buns you had in 2 dozen buns. So 2 moles of CO2, again, 2 moles, I just fill in Avogadro's constant for the word mole, and I work out how many individual CO2s I have. And then I can see that each CO2 has got 3 atoms. There's 1 carbon, there are 2 oxygens. So I work out how many CO2s I have, and then I times it by 3, because each CO2 is made of 3 atoms. And then I'm working out how many atoms I've got in total if I have 2 moles of CO2. The other thing you need to be aware of with Avogadro's constant is that you can only use Avogadro's constant if you've got moles, okay? You might not always be given moles, you could be given mass. And if you are, you're going to use your G Mr. Moles triangle, okay? So if they give you mass, you're going to divide by formula mass and you're going to get moles. And then once you've got moles, you can times by Avogadro's constant and work out how many individual atoms you have. Other thing to bear in mind is using this triangle, okay? If I had 1 mole of something, so I'm just going to fill 1 in there. Let's just say I had 1 mole of water, okay? Water has the formula H2O and the formula mass of a water molecule is 18. To work out the mass of 1 mole of water molecules, according to my triangle, mass is mR times moles. So it's going to be 18 times 1, and that equals 18 grams. So that tells me if I have 1 mole of water, so exactly 6.02 by 10 to the 23 molecules of water, it's going to have a mass of 18 grams. Okay, so the important thing to remember here is that the formula mass is the mass of 1 mole. Okay, so our formula mass up here was 18 and the mass of 1 mole of water molecules was 18 grams. Similarly here, For carbon, the formula mass of carbon is 12. If I had exactly 1 mole of carbon, it would have a mass of 12 grams. So the mass of 1 mole of carbon is the same as the formula mass of carbon. We're going to have a look now at some of the exam questions I set you so you can see what they look like. Okay, so this first question here, you're told you've got a gold ring. You're given the mass of the gold ring and you're asked to work out how many individual gold atoms, okay? If you're asked to work out the number of atoms is the number of moles times Avogadro's constant, okay? And you can see you're given Avogadro's constant in the question. That tells you need to use it. I'm not given moles in the question. Instead, I'm given mass. In order to go from moles to mass, you need to do grams divided by formula mass. Grams is 3.94. The formula mass of gold, they tell you, is 197. So gold is just a monoatomic element, okay? So it's not diatomic, so the formula mass is just 197. So I do grams divided by MR. I work out how many moles I've got. And once I know the number of moles, all I need to do is times it by Avogadro's constant, and I'm going to get my answer. The next question, you're asked to calculate the number of molecules in 0.11 grams of carbon dioxide. Now, you're asked for molecules. Carbon dioxide is a molecule, okay? You're not asked for how many individual atoms you've got in carbon dioxide. You're just asked how many carbon dioxides do you have? And just like up here, where I said atoms equals moles times Avogadro's constant, you can also say the number of molecules equals moles times Avogadro's constant, okay? But again, I don't have moles, I've only got mass. So I know I need to find moles by doing mass divided by formula mass, and you're told formula mass there is 44. So I work out my moles by doing mass divided by formula mass, and once I've got it, I'm just timesing by Avogadro's constant. Now, I don't need to multiply by 3. I know there are 3 atoms in carbon dioxide, but I'm not asked how many atoms do I have in total. I'm just asked how many carbon dioxides do I have, and this will tell me how many molecules of carbon dioxide I have. If I were asked for atoms instead of molecules, I would then need to times by 3. So the next question, we're going to see an example of that. So you're told that oxygen gas has the formula O2. O2 is again a molecule. Okay, so if you have more than one atom covalently bonded together, it's a molecule. Here I've got 2 atoms. Yes, they're both oxygen atoms, but you've still got more than one atom bonded together, so it's a molecule. But you're not asked how many O2s you have, you're asked how many individual oxygen atoms you've got. And in this case, they don't give you mass, they give you moles straight away, and again, they give you Avogadro's constant, so you know you need to use it, okay? So the number of molecules, as we saw above, is going to equal the number of moles, which is 3.5, times by Avogadro's constant. That tells me how many O2s I've got, but then you're asked how many individual oxygen atoms do you have. In each O2, you've got 2 oxygen atoms, so once you work out how many O2s you've got by doing this, you then need to times by 2 to account for the 2 atoms in each molecule of O2. The next question is different again, okay? It asks you to calculate the mass in grams of a hydrogen atom using the data below. So you're given 2 numbers. You're given the mass of hydrogen as 1, and you're given Avogadro's constant. And you're asked to calculate the mass in grams, okay? The first thing I would say here is that your answer should be tiny, okay? You're asked to calculate the mass of one individual atom in grams. Your answer should be absolutely tiny. Okay, and you're given 2 numbers, right? Even without understanding the calculation at all, if I'm given these 2 numbers that I know I have to use, and I know I need to end up with a really, really small answer, the only way I can end up with a small answer using these 2 numbers is to do 1 divided by Avogadro's constant, okay? Because that's going to give me an absolutely tiny answer. If I multiply the numbers, my answer is going to be huge. If I divide the other way around, the answer is going to be huge. But by doing this, I'll just show you, you've got 1 divided by 6.02 by 10 to the 23, and you get an answer of 1.66 by 10 to the minus 24. That's how I know the number is tiny, when I've got a minus in my standard form. Okay, in terms of why, because that is what you do. Okay, so you get 3 marks for it, 1 mark for doing this, 1 mark for actually working it out. Actually, no, you must get 2 marks for showing this and then 1 mark for working it out. In terms of why this is the way, okay, think about what formula mass means. Okay, so atomic mass of hydrogen is 1, and we said the formula mass of hydrogen is the mass of 1 mole of hydrogen. So you know that if you had 6.02 by 10 to the 23, so if you had 1 mole of individual hydrogen atoms, they would have a mass of 1 gram. But you're not asked the mass of 1 mole of hydrogens, you're asked the mass of 1 individual hydrogen atom. And if all of these hydrogen atoms have a mass of 1 gram, if I do 1 divided by this number, I'm going to find out the individual mass of a hydrogen atom. So that's it for Avogadro's constant. There are more questions in your booklet A if you want to go over a few more. But in general, if you're given Avogadro's constant, you've got to use it. You'll have to find moles if you're not given moles, and you're timesing moles by Avogadro's constant, and then just look at what you're given in the question. If you're given atoms and you're asked for atoms, you're just timesing by Avogadro's constant. If you're given a molecule and you're asked for molecule, you're just timesing by Avogadro's constant. But if you're given atoms, if you're asked for atoms but you're given a molecule, that's when you're going to have to do 2 calculations. You work out the number of molecules you've got, and then you times by the number of atoms in the individual molecule.